Then rule of the game, payoff and outcomes. Rule of the game, payoff and outcomes, strategies, number of competitors. Number of competitors. Okay, then types of game, two-person game and in-person game, two-person zero-sum and non-zero-sum game, games of perfect information and games of imperfect information, games with finite moves and games with infinite moves, constant sum game, two-person game, 2 into m and m into 2 games, 3 into 3, and larger game, negotiable game and non-negotiable game. Assumptions in the rules of the game here. So two-person games are taken into account as n-person game theory are not fully developed. However, in terms of playing the game, few rational assumptions are made. The players act rationally and intelligently. Each player has all relevant information available. Each player can use information in finite number of moves with finite choice for each move. Players make independent decisions of course of action. Players play the game for optimization. The payoff fixed and known in advance. Okay, so these things we have seen yesterday. Two-person zero-sum game. In a game with the two players, if the gain of one player is equal to the loss of another player, then the game is a two-person zero-sum game. A game in a competitive situation possesses the following. The number of players is a finite. Each player has finite list of course of action or strategy. A game is played when each player chooses a course of action strategy out of the available strategies. No player is aware of his opponent's choice until he decides his own. Okay. The outcome of the play depends on every combination of courses of action. Each outcome determines the gain or loss of each player. Then over here is saddle point. The definition of pure strategy states that both the players use the same strategy every time, and that is the best strategy from the points of view of both the players. In such a case, the strategy indicates the saddle point, which is the point of equilibrium, and it has a value of maximum gain of for A and minimum loss for B. So here we are there to find the problem. So find the solution to the play again. Find the solution. No, for game of give to the player A and B, given payoff matrix of player A. Player B strategy, player A strategy. So B1, B2, B3, A1, A2, A3. Okay. So 12, 12 minus 8 minus 2. This is the first row, and this is the second row, and this is the third row. First column, second column, third column. So these are the values are given. So see, the question is here. The game theory says that both the teams, both the players have equal chances to win the game. So that is the solution here. Player B strategy and player A strategy. B1, B2, B3, A1, A2, A3. 12 minus 8 minus 2 minus 8. 6, 7, 3, 3. And 10 minus 6, 2. Okay. So after observing the question properly, my dear students, you observe carefully. As it is, copy the question same. And if, here, additionally, you have to write here mini max. Okay. Mini max. Then this is the max mini. Max mini. Mini max means here, which is the minimum number we have to find out, and we have to write in this place. So we have to write in this place here. So you observe carefully here. See, max, mini max, and max mini here. So two things are there here. Here, 12 minus 8 minus 2. So from these three values, okay, from these three values, which is the minimum? From these three value, which is the minimum here? Wait a minute. So minus 8 is the minimum. So when look problems, when you if you see the problem, minus 2 will be looking as my minimum value, but not minus 2. Minus 8 is the minimum value. Then 6, 7, 3. Minimum value is 3. Then minus 10, minus 6, then 2. Minus 10 is the minimum value. So minus 8, 3, minus 10, these are the values. Then max mini, which here the maximum value for B1, B2, B3 are here. 12, 7, then 3. 12, 7, 3. These are the maximum value. So you observe carefully max mini and mini max values here. Okay, max mini and mini max value. The value is repeated. The value which is repeated here, 3 we got, and here also 3. So here the saddle point will be there. So select the maximum of minimum value of each row and enclose in a rectangle. Select the minimum of maximum value of each column and enclose in a circle. So first what we have to do? We have to give one rectangle here. Then next one, enclose one circle here. Enclose one circle here like this. Enclose one circle. So you will get in this way. Okay, the maximum value and minimum value coincide. Hence, the game has a saddle point equal to 3. That is B2, A2 is equal to 3. Sorry, B3, A2 is 3, and A2, B3 is also 3. So here the saddle point will be existed. So this is a problem. So here we are going to conclude that the problem is ended here only. Okay. Then we'll see the next problem. Solve the game whose payoff matrix is as follows. The next problem is solve the game whose payoff matrix is as follows. B1, B2, B3, A1, A2, A3, minus 3, minus 2, then 6, 2, 0, 2, 5, minus 2, minus 4. So you observe carefully, same question, the same procedure. In procedure, there is no change here. Okay, that is here minimax and max mini. So minus 3, minus 2, then 6, 2, 0, 2, 5, minus 2, minus 4. Minus 3 is the minimum value in the first row, and 0 is the minimum value, and here minus 4 is the minimum value. Okay, so maximum value is here 5, 0, then 6. Maximum values are these are the maximum values 5, 0, then 6. So conclusion here. So the saddle point is here 0 is the number repeated twice here, the row wise and column wise. So player A plays max mini strategy, player B plays mini max strategy. It will be seen that the minimum minimax and max mini value is 0. Hence the saddle point is 0. That is B2 A2 is equals to 0 and A2 B2 is equals to 0 here. So these are some practice problems which will help you. If you do practice, then you are going to get the complete idea about the problem. So solve the game. Choice game. Choose payoff matrix is follows. That is minus 3, minus 6, minus 5. And then 12, minus 4, 15, minus 1, minus 3, then minus 8 here. Okay, this is a one more problem. Solve the game whose payoff matrix is follows 1, 2, 3, 4, A, B, C, 20, 15, 12, then 35. Then 25, 14, 8, 10, minus 5, 4, 11, then 0. Okay, these are the problems. You please try to practice this problem. So the next topic is here mixed strategy. Mixed strategy. When the saddle point not exist, we have considering game situation which have a saddle point and observed that in such cases we are provided with an adequate theory of how best to play the game. Okay, it is possible that there is no saddle point of a game, and so it is not possible to find a solution in terms of your strategies according to max mini and mini max principle here. Okay, listen here properly. We have considering game situation which have a saddle point and observe that in such case we are provided with an adequate theory and how best to play the game. So it is possible that there is no saddle point of a game, and so it is not possible to find out its solution in terms of your strategies according to max mini and minimax principle. So game without saddle point is not correctly determined here. So games without saddle point is not correctly determined. The solution to such problem falls from employing mixed strategy. Employing mixed strategy. See, game without saddle point is not correctly determined. Without saddle point not correctly determined. So the solution to such problems falls from the employing mixed strategies. A mixed strategy represents a combination of two or more strategy that is selected one at a time. Thus, in employing a mixed strategy, a player decides to mix his choices among several alternatives in a certain ratio. In a certain ratio. Okay. So you will now we will see the problem here. The following is a payoff matrix of a game being played by A and B. Determine the optimal strategy for the players and the value of the game. Value of the game here. So you observe carefully. B1, B2, A1, A2. 8 minus 7 minus 6, then 4. 8 minus 7, then minus 6, then. See, when the problem is given, first we have to check whether the saddle point is existed or not. If the saddle point is existed, the problem will be ended there itself. If the saddle point is not existed, okay, so we go for doing the problem as mixed strategy, applying all the principles here. So first what we have to do, this is the saddle point. See, B1, B2, A1, A2, 8 minus 7 minus 6, then 4. So here row minimax. Row minimax means here 8 minus 7, then minus 6, then 4. So the minimum value is minus 7 and the minimum value is minus 6. So maximum value is 8 and here maximum value is here 4. Okay. So this side and this side, if you observe carefully, this side and this side, if you observe carefully, the same number is not repeated. Same number is not repeated. Then we can say that no saddle point existed here. So at this situation, what we have to do? We have to do here means here. See, first, what we have to do? We have to write the conclusion here. In the given problem, say in the given problem, mini max and max mini values are different. Hence, the given problem does not have a saddle point. Hence, the given problem does not have a saddle point. Therefore, optimal strategies and game value calculated as follows. The following is the payoff matrix of a game being played by A and B. Determine the optimal strategies for the players and the value of the game and the value of the game here. So that is B strategy and A strategy here. So see, yesterday what we done, yesterday we have seen that payoff table. Okay, payoff table we have seen yesterday. So in that payoff table, see, generally payoff table, we have to decide the places here. We have to decide the places, that is B1, B2, A1, A2. So you observe carefully. See, in the given problem, max, mini, and minimax values are different. Hence, the given problem does not have a saddle point. Therefore, optimal strategies and the game value calculated as follows. The value of x is equals to A22 minus A21 divided by A11 plus A22 minus A12 plus A21. This is the x value principle and y value principle and v value principles we have to do. Okay, this is the principle here. Just remember this principle very carefully. A second row second column minus A second row first column divided by A first row first column plus A second row second column minus A first row second column plus A second row first column. Okay, the value of y. Value of y means here A22 minus A12 divided by A11 plus A22 minus A12 plus A21. A12 plus A21 here. The next calculation of game value v is equals to A11 into A22 minus A12 into A21 divided by A11 plus A22 minus A12 plus A21. This is the another principle here. A22 minus A21 divided by A11 plus A22 minus A12 plus A21. Okay, so second row second column, second row first column, first row first column, second row second column, first row second column, second row first column. So these values we have taken according to the places. Then here optimal strategy of A1 is equal to 0.4. Okay, 0.4. Then A2 is equal to 0.6. See, always the probability should be 1 or below 1. 1 or below 1. That is 0.99 or below. So we can say that. But ultimate, the overall answer should be 1. Overall answer should be 1. This is the case. A22 minus A12, A11 plus A22 minus A12 plus A21. Then the game value V is equals to A11 into A22 minus A12 into A21 divided by A11 plus A22 minus A12 plus A21. So here you observe carefully the value of Y. Value of Y here. Value of Y is equals to A22 minus A12. A22 is a common. Only change this one is changed. See here this new denominator and this denominator values are same. Why? Because the principle is the same here. Okay, you observe carefully. A22 minus A21 divided by A11 plus A22 minus A12 plus A21. Yeah, sorry for interruption. There's a small power cut. Just now the power came. Okay. Wait a minute. I will share the screen also. Okay, stay here. So this is the payoff table, and this is the places where we decide. Just now we have seen that in game there is saddle point P first row, first column, first row, second column, second row, first column, second row, second column in this way. So in mixed strategy, so these are the problem. So we are now just now we are discussing this one only. So value of x is equals to a22 minus a21 divided by a11 plus a22 minus a12 plus a21. Okay, optimal strategy here. The value of y is equals to a22 minus a12 divided by a11 plus a22 minus a12 plus a21. Then here the value of the game a11 into a22 minus a12 into a21 divided by a11 plus a22 minus a12 plus a21. See, you observe the formula here. So, yeah, so you observe carefully. A21 minus A20, A22 minus A21 divided by A11 plus A22 minus A12 plus A21. Okay. Then A22 minus A12 divided by A11 plus A22 minus A12 plus A21. Right? Then A11 into A22 minus A12 into A21 divided by A11 plus A22 minus A12 plus A21. So you observe carefully here. A11 into A22, A12 into A21. See, this is here multiplication, but here addition only. Multiplication, then addition. Okay. So with this, we can say that when saddle point is not existed, in this way, the value of x, the value of y, and the value of v, these three principles we need to apply. We need to apply these three principles. Then only we are going to get the answer. Okay, this is a procedure to calculate and mixed strategy in a mixed strategy here. Then next over here. Note, in the given problem, if it is 22 matrix, there is no saddle point, then do the above practice, the above method. Okay, and these are the practice problem. See, my dear students, you observe carefully. When 2 into 2 matrix size is there, then only it is possible. Then only it is possible to do this problem. Otherwise, it is not possible. Okay, if a saddle point is, say, when question is given, 3 into 3 columns or 4 into 4 columns or 5 into 5 columns, we have to check whether the saddle point is existed or not. Okay, if saddle point is existed means the problem is ended there itself. If the saddle point is not existed, then only we need to do mixed strategy method. Mixed strategy method. So you observe carefully here. So here only two rows and two columns are there. Two rows and two columns are given. Then what we have to do? Simply we have to check whether saddle point is existed or not. If saddle point is existed means the problem is ended. If saddle point is not existed means simply we have to apply the value of x, value of y, and the value of v. These three principles we have to apply. These three principles we need to apply. Okay. After the application of these three principles, the next find the optimal strategies. See, these are the practice problems. Find the optimal strategies and the value of the game for the following pair of matrix concerning two-person games. Two-person games. It is B strategy and A strategy. 1, 4, 5, 3. Okay, 1, 4, 5, 3. Then B strategy is 12, 8, then minus 6, then 4. Okay. So see the mini max, and this side max mini. So which is the minimum? 1 is minimum, 3 is minimum. Which is maximum? 1 is max. Say 5 is maximum and 4 is maximum. So you observe carefully. Okay. So here no saddle point existed. We have to apply value of x, value of v, and value of y. Then again one more problem. Minus 8, minus 6, then 12, next is 4. So here also no saddle point. Here also no saddle point. Simply again we have to apply value of x, value of y, and value of v. Okay, this is the procedure. So at this we completed a saddle point and mixed strategy problem. Saddle point as well as mixed strategy problem. Then we go for the dominance method. We go for the next method, that is the dominance method. In a game, sometimes a strategy available to the player might be found to be preferable to some other strategies, such as a strategy is said to be determinate the other one. Determinate the other one. A game in which a player has more than two choices, while the other player is limited to two choices, is denoted by 2 into m or m into 2 game. The concept of dominating strategy is very useful for reducing the size of payoff matrix. Wait a minute. Okay. So here, dominating dominance strategy. So this is a very much important problem. So in a game, sometimes a strategy available to player might to be found to be preferable to some other strategies. Such a strategy is said to be determinate the other one. A game in which a player has more than two choices. Okay, more than two choices, while the other player is limited to two choices is denoted by 2 into m and m into 2 game. The concept of dominating strategy is very useful for reducing the size of payoff matrix. Reducing the size of payoff matrix. So the rule, see, listen here, this is very much important. In the given problem, for example, when the row size is increases, 2 into 2 rows or 3 into 3 rows or 4 into 4 rows. Okay, so at that time, what we have to do? See, we have to check the same procedure we have to follow. Same procedure we have to follow. Okay, we have to follow the same procedure. That is whether the saddle point is existed or not. So we have to check whether the saddle point is existed or not. If the saddle point is existed, means the problem itself it is ended. If the saddle point is not existed, okay, if this saddle point is not existed, then what we have to do? We have to reduce the size of matrix till a 2 into 2 matrix size, till 2 into 2 matrix size it is. Okay, when the matrix size is reduced to 2 into 2, then only it is possible to check again whether the saddle point is existed or not. If the saddle point is existed, the problem will be ended. If a saddle point is not existed, okay, then the matrix size is 3 into 3 columns are there. So simply what we have to do, we have to reduce the matrix size here. So the rules are there here. So check the rules properly. Okay, listen the rules properly here. The concept of dominating strategy is very useful for reducing the size of payoff matrix. Okay, that is here. Rules for dominance. The following two are the rule for dominance. Number one and number two. If all the elements in column are greater than or equal to corresponding elements in another column, then that column is dominated. If all the elements in a row are less than or equal to corresponding elements in another row, then the row is dominated. After finding out the dominated columns and rows, they may be deleted, which reduces the size of the game. Okay, always look for a dominance while solving the game. So you observe the problem. This is a problem. This is important problem. So I think if you understood this problem, then it is very easy that dominance method is okay. So find out the best strategy and the value of the following game. Find out the best strategy and the value of the following game. So B is a strategy, A is a strategy. Okay. Here B strategy here uh, -1, -2, then 8, 7, 5, -1, 6, 0, then 12, 6, 0, then 12 here. Solution here, check if the saddle point existed or not. So B strategy, A strategy. A strategy is here -1, -2, then 8, 7, 5, -1, 6, 0, 12. So you observe carefully. See minimax and max BT. -2, -1, then 0. 5, 7, 5, then 12. So here, which is the minimum? -2 is the minimum here. -1 is the minimum. Then 0 is minimum. Then this side, 7 is maximum, 5 is maximum, and 12 is maximum. So no saddle point. Since max mini value is not equal to minimax value, saddle point does not exist. Okay. So apply dominance principle to reduce the size of the matrix. Size of the matrix, that is row dominance. Row dominance, compare R1 and R2. Compare row 1 and row 2. This is row 1, row 2, and row 3. Next one is column 1, column 2, then column 3. R1 and R2. So you observe carefully. R1 and R2. Minus 1, this minus 1 is, when comparing with 7, it is a small number. So minus 1 less than or equal to 7, less than 7. Then minus 2 less than 5, minus 2 less than 5. Then 8 greater than minus 1, 8 greater than minus 1. So first comparison is completed. Compare R1 and R2. Then compare R1 and R3. Compare R1 and R3. So comparison of R1 and R3. So that is here. Compare R1 and R3. So this is R1 and this is R3. See, minus 1. Okay, minus 1 less than 6. Then minus 2 less than 0. Minus 3, sorry, minus 8 less than 12. Less than 12. So this is the case. So R1 and R3 also completed. Then compare R2 and R3. R2 and R3. These are the R2 values. These are the R3 values. 7 greater than 6. 5 less than 0. Minus 1 less than 12. Okay. So in R1 and R3, every element of R1, see, in R1 and R3, I'll show you here. R1 and R3, every element of R1 and R3 are less than, every element of R1 less than or equal to R3. Hence R1 is deleted, the reduced pair of matrices. So R1 will be deleting here. So we are going to delete this one. So the reduced pair of matrix will be written there. So you check, so you see the reduced pair of matrix. R1 and R3, every element of R1 less than R3, hence R1 is deleted. The reduced payoff matrix is here. B strategy, A strategy. 1, 2, 3, 1, 2. 7, 5, minus 1, 6, 0, then 12. This is a reduced payoff matrix. Then after reducing the row dominance, after completion of row dominance, we go for the column dominance. Okay, we go for the column dominance. In column dominance here, compare C1 and C2, compare C1 and C3, compare C2 and C3. So here is the comparison of column 1 and column 2 here. So column 1, 7, see comparison R1, see C1 and C2. This is C1, this is C2. 7 greater than 5, 6 greater than 0. Then C1 and C3. 7 greater than minus 1, 6 less than 12. C2 and C3. 5 greater than minus 1, 0 less than 12. Okay. So here in C1 and C2, every element of C1 greater than C2, hence C1 is deleted. The reduced payoff matrix is as follows. So C1 is deleted. We are going to delete this one. So the reduced payoff matrix is 5 minus 1, 0, 12. See, the matrix size is slowly decreased to 2 into 2 columns. 2 into 2 column here. So B is strategy, A strategy. 5 minus 1, 0, 12. This is a reduced payoff matrix here. 5, 0, minus 1, then 12. So you observe the size of the matrix is 2 rows and 2 columns. 2 rows and 2 columns are there. 2 rows and 2 columns are there. So this is the important point. So after reducing the matrix size, reapply max mini and mini max principle to check if saddle point existed or not. To check if the saddle point existed or not. So here B strategy, A strategy. So 1, 2, 1, 2, and 5 minus 1, 0, then 12. So here 5 minus 1, that is minus 1 is a minimum, 0 is a minimum, then 5, 0. Max mini, okay, 5 is a maximum, and here 12 is a maximum. So you observe carefully here, this side and this side. Same number is repeated, both sides. Minus 1 is repeated, no, it is not repeated. 0 is repeated, no, it is not repeated. Then 5, it is not repeated. 12, it is also not repeated. Since max mini value is not equal to mini max value, saddle point does not exist. Therefore, optimal strategies and game value calculated as follows. Calculated as follows. So here, then what we have to do go? We have to go for calculating the value of x, value of y, and value of v, value of x and value of y and value of v. So value of x is equals to a22 minus a21 divided by a11 plus a22 minus a12 plus a21. Okay, then you do the calculation part. So a22 minus a21 divided by a11 plus a22 minus a12 plus a21. So here the value of y, a22 minus a12 divided by a11 plus a22 minus a12 plus a21. Okay, so here a22 minus a12 divided by a11 plus a22. Okay, here a12 plus a21. The next, the value of game v, a11 into a22 minus a12 into a21 divided by a11 plus a22 minus a12 plus a21. So these are the values. So at this we completed the dominance method also. So the limitations of the game theory. So here are the some limitations. Even though our limitations are nothing but disadvantages. Okay, even though advantages are there in any problem, there will be disadvantage also. Okay, so you observe carefully. The basic presumption in game theory is that loss of one competitor will be the gain of other. But practically, there is no application of game theory in real life situation because the strategies of the competitors and their payoff are not normally known or cannot even be predicted. When there is a lack of definite information of data, the principle of max mini and mini max cannot be applied. Thus, the alternatives left with the manager are that taking risk. These are generally are likely to be more than two competition, and hence balancing of gain and loss is also not always possible. These are called non-zero sum games. These are called as non-zero sum games. Then here variables and uncertainties being very large, games have an infinite number of pure strategies involved, and the solution of the game is more and more complicated. Okay, so this is about the statistical decision theory. So if anybody have any doubt, you can ask the doubt. So now you are welcome to ask the doubts. So my dear students, if anybody have any doubt, you can ask the doubt. Okay, just I will scroll down the first from beginning. So you go through once. So what we discussed, just you go through statistical decision theory. So this is the statistical decision theory. See decision theory. So they about the definition and examples are yesterday we have seen. To complete all these things, yesterday we have seen. But once, suppose once we are moving to the new topic, before that, just go through once again here. So here are the examples and the definitions. These are the definition. Then steps in systematic problem solving here. Ingredients of decision problem, act, states of nature or events, payoff table. Then problems here. Preparation of payoff table. Then last table. From last table, calculate payoff table. Decision making environment, next one. Decision maker, objective, decision situation. Okay. Then optimal decision. Game theory, terminology, strategy, pure strategy, mixed strategy, saddle pant, minimax criterion, value of the game, rule of the game, payoff and outcomes, strategies, number of competitors, types of game, assumption in the rules of game, 2% zero sum game, saddle point. Okay, then problems. So these are the problems here. Then mixed strategy. In saddle point, just now we have discussed. Okay, when saddle point is not existed, you go for applying mixed strategy method. Mixed strategy method. Then dominance strategy, rule for dominance. Then problems here. The limitations of the game theory. Okay, so anybody any doubt regarding the topics what we discussed here? So once we go, we'll see the syllabus once again. Yeah. So we completed the problematic part here. So we'll start theoretical concepts here. So that is from the block one, the quantitative techniques, basics of research, process of research, data collection techniques, interpretation of data and report writing. Hmm? So correlation we completed, regression completed, business forecasting, probability. So we'll see if the probability is available or not. Wait a minute. Right. So we'll see the probability chapter. So wait a minute. So probability chapter we'll discuss now. Okay, in probability always one or less than one, should not be beyond one. So be patient. I'm searching for probability chapter. Meanwhile, I will share the screen also now. Wait. Yes. See, probability. In probability, elements of probability, meaning of probability, concept, sample space, sample points, and events, types of probability, prior probability, empirical probability, subjective probability, calculation of probability, fundamental rules of probability, okay, conditional probability, statistical independent Bayes theorem. Okay, so important points we are going to see today. Okay, so the coming to introduction part here. The word probability or chance is very commonly used in day-to-day conversion, and generally people have a vague idea about its meaning. We come across the statements like probably it may rain tomorrow. It is likely that Mr. X may not come for taking his class today. The chances of team A and B winning a certain match are equal. Okay, it is possible that I may not be able to join at the tea party. All these terms are possible, probably likes, convey the same sense. That is, event is not certain to take place, or in other words, there is uncertainty about happening of event in question. Okay, event in question. Sure. Without probability or chance. So certainly or uncertainly things will happen or may not happen. So generally, a statement is like that. Probably it may rain tomorrow. May or may not. The equal chances are there. Okay. Probably the equal chances are there. The next over here, brief history of the probability. The theory of probability has its origin in the game of chance related to gambling, such as throwing a dice, tossing a coin, drawing cards from a pack of cards. And Girlo and Cardino, 1915-01 to 1976, an Italian mathematician, was the first man to write a book on the subject entitled A Book on Games of Chance, Liber di Ludo Elio, which was published after his death in 1663. Galileo, 1504 to 1642, an Italian mathematician, was the first man to attempt quantitative measures of probability while dealing with some problem related to theory of dice in gambling. However, systematic and scientific foundation of the mathematical theory of probability was laid in mid 17th century by two French mathematicians, B. Pascal, 1623 and 62, and Prieur de Format, 1601 to 65. Then you will see the definition. Okay, the probability of a given event is oldest expression of likelihood or chance of occurrence of an event. A probability is a number which ranges from 0 to 1. A probability is a number which ranges from 0 to 1 for an event which cannot occur, and 1 for an event certain to occur. However, the number is assigned would depend on the interpretation of the term probability. Term probability. Okay, classical or a prior probability. A classical approach to probability. So wait a minute.